Hello, I'm Mrs. Arnold, and today we will be learning about the properties of the atmosphere. The main idea is that atmospheric properties such as temperature, air pressure, and humidity describe weather conditions. Questions you should be able to answer at the end are: what are the three main properties of the atmosphere and how do they interact? And why do atmospheric properties change with changes in altitude? Our first property is temperature. So temperature exists because particles have kinetic energy when they are moving faster. I should actually say particles have more kinetic energy when they are moving faster. And the higher the temperature of the material, the faster then the particles are moving. Higher the temperature of the material, the faster the particles are moving. And then, of course, that means they have more kinetic energy than something that has a lower temperature. The way we measure this temperature is by Fahrenheit, Celsius, and Kelvin. So let me highlight Fahrenheit too. So Fahrenheit, Celsius, and Kelvin are the ways that we measure temperature. And you can see from this chart that it shows you at what temperature water boils, freezes, and what absolute zero is on each of the different charts that we use. Okay. Air pressure is the pressure exerted on a surface by the weight of the atmosphere above the surface. This is measured in millibars. And 1 millibar equals 100 newtons. Per square meter. So that means 1 millibar is 100 newtons. So that is the weight. Newtons is a measurement of weight over a square meter. Air pressure is going to decrease as you go higher in the atmosphere, which makes sense, especially considering that 90% of the mass of the atmosphere is in the troposphere. I believe that's what we talked about in the last video. Air density is the mass of material per unit volume. So density is the mass of material per unit volume. You might recall us doing an experiment. So the formula for density is density equals mass over volume. We did a lab with density. With the atmosphere, if you look here at this picture, we have the pressure at 500 millibars, and we also have density at 0.5 kilograms per cubic meters. But as you go up, you can see that number gets smaller for both. So what I want to write here is that density and pressure of atmospheric layers decrease as you go up. In the atmosphere, the temperature, pressure, and density of air are related to each other. What we see in this first example here is that if temperature increases, but density is constant, then pressure increases. Here in our second graphic, what we see is if temperature increases, but instead of density being constant, pressure is constant, then density decreases. A temperature inversion is when the temperature-altitude relationship is inverted or turned upside down. Remember, in the troposphere, temperature is going to decrease as you go up in altitude, but an inversion inverts that. Okay, it switches it. So the colder air in this case would be lower in altitude and the warmer air is sitting on top. Why would this happen? So some causes of a temperature inversion can happen if the land doesn't radiate thermal energy to the lower layers of the atmosphere. That can happen on cold, clear winter nights when the air is calm. Then what will occur is the lower layers of air become cooler than layers above. Okay? What effects can this have? You can actually see an effect of a temperature inversion here in this picture of New York City. So we have a hazy sky. We can also see fog or low level skies. This inversion can worsen air pollution problems in some cities. Imagine you are entering a large air-conditioned building on a hot summer day. As you open the door, you feel cool air rushing past you out of the building. This is occurring because the warm air outside is less dense in low pressure and lower pressure than the air inside the building. So what you are experiencing in that moment is wind, which is defined as the movement of air. Wind and pressure differences. So we experience wind due to the pressure differences. So in the little scenario I gave you, wind occurs because there's a pressure difference between the inside air and the outside air. How does the air move, you may ask, to create the wind? So air is going to move from the regions of higher density in pressure to regions of lower density in pressure. These density differences are created due to the Earth not being heated equally by the sun. So they're produced by the unequal heating and cooling of Earth. What we see in the atmosphere is that pressure is going to increase. So in the atmosphere, actually I should put pressure first and then the arrow. Pressure increases as density increases. So you have more particles in air mass, it's going to have a higher pressure, basically. And what we also see in the atmosphere is air moves from high pressure to low pressure, creating wind. I've also noticed this happening in some of the science classrooms. If you open the classroom door, you can feel a rush of air coming into the room, which tells me then the air is rushing in. So the air in the hallway must be at a higher pressure than the air inside of the room. Wind speed is also affected by the altitude. So near the Earth's surface, wind speed is going to be slower because of friction. Wind is constantly in contact with surfaces like trees and buildings and hills, which slows it down. But higher up at a higher altitude, the air is going to encounter less friction and wind speeds increase. Humidity is a measure of the amount of water vapor in the atmosphere at a given location on Earth's surface. We describe humidity using relative humidity, which you've probably heard that term, especially in weather forecasts. And also dew point, probably another term you've heard if you listen to the forecasts. Relative humidity is the amount of water vapor in a volume of air relative to the amount of water vapor needed for that volume of air to reach saturation. Okay, so first let's define what saturation is. Saturation happens when the amount of water vapor in a volume of air has reached the maximum amount possible for that temperature. So different air temperatures can hold different volumes of air. And of course, when air is fully saturated, it cannot hold any more water. Going back to relative humidity, then, if we say if the relative humidity is 50%, that means air contains 50%, whoops, it looks like 50% of the water vapor it needs to be fully saturated. The dew point is going to be the temperature to which air must be cooled at constant pressure to reach saturation. When air cools to this point, then condensation happens, which means we get water or dew. Condensation occurs because water is going to condense in dew forms. If the dew point is nearly the same as the air temperature, then you know that the relative humidity is high. So let's say that the dew point for the day is 65 degrees. And our temperature for the day is 65 degrees. Then we know that relative humidity is basically 100%. Latent heat, this is the energy that is released when water vapor condenses into a liquid. So remember, water vapor is in a gas state, so it has higher energy, but when it goes and condenses down into a liquid, it is going to be at lower energy, and that energy that is released is going to be the latent heat. So this is exothermal energy contained in water vapor compared to liquid water. And this energy is going to provide energy to weather systems like hurricanes. And that can increase the intensity of the storm. Okay, so air masses can also change its temperature without being heated or cooled. You might ask, how does it change temperature without it being heated? That is going to happen because its volume changes. So happens because it is compressed or expands. So AKA volume changes. Volume gets larger or gets smaller. We have different terms for this. We have adiabatic heating. This is going to occur when air is compressed. Okay, so the volume it takes up is decreased. And that means that the temperature increases because the pressure increase due to the air being compressed. And then we have adiabatic cooling, which occurs when air expands. And in this case, the opposite is occurring than the heating. Temperature decreases because pressure has decreased. Condensation is going to occur at something called the lifted condensation level. Once again, remember that condensation, when condensation occurs, we have water vapor going into liquid water. So it's no longer gas. We're going to see cloud formation. Okay. So a rising air mass cools as it rises because there's less pressure around it. So because pressure decreases as it rises, which causes the air mass to expand, which is adiabatic cooling, which we just talked about in the last slide. Now, this is going to be different for if you have dry air versus if you have moist air. If the air is dry, so the dry adiabatic rate is the air mass temperature is going to go down 10 degrees Celsius for every 1,000 meters, if you're talking about the air going upwards. If the air is moist, then you can see from the chart it decreases in temperature by 4 to 9 degrees Celsius for every 1,000 meters. And you might ask, why does it have a decrease by smaller numbers for the moist versus the dry? That is because the water vapor that is in the air mass is condensing, and as it's condensing, it's releasing that latent heat energy that is keeping the air mass warmer than it would be otherwise if it didn't have that water that is condensing. Okay. Today we learned about the different properties of the atmosphere, which are temperature, air pressure, and humidity, and how they are used to describe weather conditions. I hope you have a wonderful